Hello, today we're going to talk about the infinite I power tower. We're going to try to solve it together. Now, if you're already or familiar with the Lambert-Early function, I encourage you to pause the video and try to figure it out for yourself. If you're not, then go ahead and watch. Well, we start by naming our infinite I power tower y. And then we make our first observation, which is y is equal to I to the y. We take the natural log of both sides. That leaves us with ln of y is equal to ln of I to the y. And by logarithm rules, that means that the natural log of y is equal to y times the natural log of I. Dividing both sides by y, we get ln of y over y is equal to ln of I. Replacing y by e to the ln of y, we get that the natural log of y over e to the natural log of y is equal to the natural log of I. That leaves us with ln of y times e to the negative ln of y is equal to ln of I. And I'm just gonna add a negative sign to both sides. You will see why right now. Well, let's put that on top. And remember the Lambert W function that we talked about 2 videos ago. If you haven't watched that video, I highly encourage you to go check it out. Well, the Lambert W function was defined as the inverse function of x e to the x. That leaves us with the Lambert W of x e to the x being x. And so when we plug the Lambert W function into both sides of the equation, we get that the Lambert W function of negative log of y e to the negative log of y is equal to the Lambert W function of negative log of I. Well, since we can call negative log of y x, that will give us that the Lambert W function of x e to the x being equal to the Lambert W function of negative ln of y. So the function of the left cancels with its inverse function, and we're left with the negative log of y is equal to the Lambert W function of negative log of I. And so we're left with the log of y is equal to the negative Lambert W function of negative ln of I. Exponentiating both sides, we're left with y is equal to e to the negative Lambert W function of negative ln of I. Well, Euler formula tells us that e to the I theta is equal to cosine of theta plus I sine of theta. Try plugging in theta for pi over 2. That will leave us with I is equal to e to the pi I over 2, because cosine of pi over 2 will be 0 and sine of pi over 2 will be 1. That means that the natural log of I is pi I over 2. And so this simplifies to y being equal to e to the negative Lambert W function of negative pi I over 2. And you get our numerical approximation for this, which becomes that the approximation of y is 0.43828. This is the real part, and the imaginary part being 0.36059. You can see that indeed this converges to the value we calculated as I put more i's into the exponents. If you liked the video, don't forget to like and subscribe and share it with your math crazy friends. And until next time, go Physimathize the world.